X-intercepts of rational functions. What are they? When you've talked about x-intercepts in the past, the term you might remember for polynomials is the zeros of a function. Where were the zeros of the functions? All the places where it crossed the x-axis, right? So if I took this polynomial, these would be my zeros of the function. But we can have zeros of the function with rational functions as well. And we also call them x-intercepts. It's the same thing. So I'm going to go ahead and draw a rational function here. I'm going to give it a horizontal asymptote at about 1 and a couple vertical asymptotes. This one looks like it's about at 1. This one is at maybe -4 or so. And I'm going to draw a graph. Where are my x-intercepts? Right here and right here. This one looks like it's maybe at -7, 0. This one, maybe about 6, 0. Okay. What is true always when the x value equals 0? I'm sorry, when it's crossing the x-axis. Well, actually, the y value is going to equal 0 in these. So when does the graph cross the x-axis? When y equals 0. So let's take a look at it for instance here. Let's say I have the function y equals 2x minus 10 over x squared plus x minus 2. And something you're going to want to remember here, you've probably already done it if you're at this point in the function, but you need to make sure you have factored. Okay? Let's go ahead and factor this function. What can we pull out of the top? Pull out a 2, and we're left with x minus 5. And on the bottom, we're going to have x plus 2, x minus 1. So where would this whole thing, where would y equal 0? Well, it would be where y is this whole thing, right? So when does this equal 0? Well, if the bottom equals 0, it's going to be undefined. So really what we need to find out is when the top equals 0. Okay, so let's take a look at the top. Well, 2 can't equal 0, but x minus 5 can equal 0. And when does that equal 0? At 5. So our x-intercept here, or our 0, is 5, 0. Okay, so you'll notice we factored the top, and we found where the top equals 0, because that's where the whole thing is going to equal 0. 0 over anything I have on the bottom, it doesn't matter what it is always going to give me 0. Let's take a look at one more of these. Y equals x squared minus 2x minus 8 over x squared minus 6x plus 8. Go ahead and pause the video and factor the top and factor the bottom. When you factored that, you should have gotten x minus 4, x plus 2 over x minus 4, x minus 2. Now, when we were trying to find the x-intercepts, we said, where does the top equal 0? But there's an important thing we have to notice here first. The top equals 0 at x minus 4, but so does the bottom. So this is going to cross out. This actually tells us a hole, if you remember from earlier. We're going to have a hole at 4 something, and we'd have to plug that 4 back in to find out what that something is. So a factor that doesn't cancel is not going to tell us an x-intercept. We have to look at the other one. Where does x plus 2 equal 0? Well, at -2. So my x-intercept is at -2, 0. Let's just think through what else we know about these graphs and what other information can we find. Are there any vertical asymptotes? Yeah, at x equals 2. We know that from the bottom. Where the bottom equals 0 and it doesn't cancel with the top, that gives us a vertical asymptote. So what about horizontal asymptotes? What do we look at for horizontal asymptotes? The degree of the top and the bottom and how they compare. Well, they're the same, so what happens when they're the same? Our horizontal asymptote is going to be y equals the ratio of the leading coefficients. In this case, we've got 1 and 1. So y equals 1 over 1, which is 1. So just from this one function, I can find all of these things, which is what we're going to be doing in the next video in graphing, which you are ready to do now. You are ready to graph rational functions. Can't wait to see you for the next video.